cutting a few race tracks down the racetrack here, and we're looking at viscosity. And I just wanted to introduce you briefly to the concept of viscosity. So viscosity is actually the resistance of a fluid to the flow of basically when a fluid's flowing, the molecules have to be able to run over the top of each other for the liquid to flow. And when you have a high viscosity, it means that there's more resistance to flow, and that's usually related to the size of the molecules. So bigger molecules that are more complex chains, they tend to tangle up in each other, so they won't flow over the top of each other. And also the polarity and the intermolecular forces. So when we have stronger intermolecular forces, then the molecules are more easily attracted to each other, so they won't flow over the top, so they stick to each other more. If you just zoom in here, there's some notes if you guys want to have a look at those notes. So viscosity, resistance of fluid to flow, depends on the internal friction between the molecules. Longer chains of molecules get tangled. Molecular shape also has an impact, and increased temperature usually leads to a decrease in viscosity, and that is because you've got more energy in a higher temperature, so those intermolecular forces are more easily broken.
Substance, time, speed.
There'll be our results.
So this is golden syrup on the right, chocolate topping in the middle, and honey on the left.
Okay, we zoom on in, ready, set, go. Oh, the race is tearing away. This is off the charts. Looks like honey's taking the lead, closely followed by golden syrup.
Looks like only honey's going to reach the end.
And chocolate syrup is really dragging the chain at this point. Making for some great spectating sport, this race of the syrups.
So good.
We did opt for the slowest liquids to kick off things, so hopefully things will get a little more exciting as the day wears on. So,
We're going to there.
Beg your pardon?
We're going to there.
Yeah, that's our 25 centimetre. So Ethan, while this exciting race is underway, do you want to explain maybe why you think the three are exhibiting what we see here?
I reckon that chocolate topping has a big chain of things, molecules.
Yep.
And so they get tangled up.
So what would chocolate topping be made out of? Do you remember the name of that substance? Sugar. Yep. Glucose. They should all be made of glucose. So there must be other things involved.
And also temperature.
Temperature. Yep. But they're all the same temperature. That would be actually interesting. I don't know what the different chains would actually be, what the chains would be in these. And glucose.
And fructose makes it go quicker.
Yeah, probably.
Here it comes, coming up in the end.
It's down the last bend and it's neck and neck.
He's past the finish line.
3 minutes 17:52. What a killer pace. That is the record of the day.
So far.
So far.
And then this one on second, which
Let's
made
just
about
measure
halfway.
him. Let's just measure him and just decide.
Chocolate topping cooked it.
Chocolate topping had absolutely nothing. 11 centimetres.
11 centimetres. There he goes. Winner. Second.
Okay, you can do the shots quickly. 2, 1, go.
Alright.
And that was like to glycerol, and we're going to see if we can crack walking speed. we go. 3, 2, 1, go.
Damn it.
Yeah,
we're gonna beat walking
I
speed.
don't think walking speed is going to be correct on this particular scenario. Glycerol is definitely in no hurry. It's in so little of a hurry that these little deviations in the plastic are really playing havoc.
Here it comes.
It's making a late charge to the finish line. There's a few obstacles there for it to negotiate, but I think it's going to come through with quite a pleasing score. What do we have there?
45.97.
5 seconds.
44 really though.
We're just trying Ethan's urine this time round. He's kind enough to donate a little sample for us. Okay, count it down for me, Ethan.
This is water. 3, 2, 1.
Oh, that was quick.
That was very good.
Same non-polar solvent.
I'll count it. So 1, 2, 3, go. Ready? 1, 2, 3, go.
Ooh, 0.63.
Beats.
3, 2, 1, go. Scene. Final countdown. 3, 2, 1, go.
Yep. That was in a 4.65.
Record break. Okay, so as you can see from our wonderfully comprehensive results table, the different liquids exhibited different viscosities, and therefore their time trials yielded different results. This was largely due to the interaction of the cohesive and adhesive forces that were at play between the liquids and the material on which the liquids were racing. Thank you and good night.